Thanks a lot, Manny. It's super fun to be here at SauceCon. And I remember 8 months ago, last SauceCon, I did talk about technology and what it means to be human and automation and philosophy. That was super fun. So we're going to go completely the other direction this time. We're going to talk pure Appium, and we're even going to get into the guts of some coding together, which should be entertaining, if not something you can take away and use for yourself. So so we're going to talk about Appium's drivers today and how Appium is architected to take advantage of different sort of encapsulated drivers that provide all the automation capabilities for the different platforms you care about automating. So we could just call this talk, Let's Build a Driver instead, because that's what we're going to be doing after a brief introduction. I've already been introduced. So very, very long time ago, like 5 years ago, Appium was brand new. We had just kind of taken it from the brains of Dan Cuellar and Jason Huggins and started to turn it into something that people could really use. And we started to rewrite it and write it from scratch in JavaScript and all that. And I went around talking about Appium, and this is one of the diagrams that I used to present on how Appium is architected. So you have your WebDriver script, and then you've got this thing called Appium, which is basically a WebDriver controller, a little web application that responds to the WebDriver protocol. And then we have some stuff that was hooked into Apple's proprietary automation technology called instruments in UI automation. So if I were to present it less graphically and a little bit more schematically today, this is what Appium looked like at the beginning. Again, your test script, your Appium process written in JavaScript, instruments in UI automation, which we're running as a kind of secondary or sub-process to Appium. And then you had your iOS device, and how instruments in UI automation talked to your Apple device was just up to Apple. I mean, you don't really know how it works under the hood. But the little lines here have text on it to say this is how the communication happens. So we had JSON wire protocol between the test script and Appium, and then we had a very hacky Unix socket-based command queue to essentially shove commands into instruments in a way that it was never designed to do. Anyway, it's a super interesting story. Hopefully we'll get a chance to do a talk on it sometime. But this is it. This is Appium. It started with just iOS support. Very quickly we added Android support, and so the architecture got a little bit more complicated. We now still had this one WebDriver interface, but depending on the platform you selected and your capabilities, we would either do the Unix socket command queue to instruments and talking to an iOS device, or we created an entirely different way of speaking to something called UI Automator, which had been put out by Google very recently. It was, at the time we implemented our Android support, the new hotness from Google, and it was very quickly not the new hotness anymore because Google constantly is introducing new automation technologies. But it was pretty awesome at the time, and we built a little network communication mechanism between some code running in the UI Automator context and Appium itself. So that's how JSON wire protocol got translated into UI Automator-based behaviors. So the thing to really observe here is Appium is not this whole picture. Appium itself had a very limited role. And that role was just to translate WebDriver commands from your test script into whatever we needed to do to make things happen on the device. And it just so happened for iOS, it was instruments and UI automation. And for Android, it was UI Automator. And I said it's this very thin layer, and that's a little bit of a lie because we actually had to write tons and tons of code in instruments or in the UI Automator context to affect this translation. And that's where a lot of the value came from for you guys from Appium, because we actually made it possible to write WebDriver test scripts and have it do all these things. But conceptually, Appium is just this very simple little idea. So talk a little bit more about that vision, where we've come from, where we're going. Jason Huggins just got done giving this amazing talk and mentioning star driver, right? So this is an idea that we've been playing with, and Appium, perhaps foolishly, maybe stupidly even, has chosen not to constrain itself in the way that the Selenium project has, was really sticking to supporting web automation. And they're very smart, because it means that they will eventually finish their project and get to move on to other things. Appium instead has said, like, hey, we'll try and be star driver, I guess. If there's people out there that can build these different drivers for different things, we'll be a big kind of friendly community of drivers. So all that the Appium of the future is really going to be, in a kind of pure sense, is hopefully someday an official extension to the WebDriver protocol that Simon and David Burns and all these other people have been working on. They've spent years making it really great for web automation, but we're going to need to automate other kinds of things. The need has been there for some time to automate mobile apps. The need is present to automate other kinds of applications. And rather than give up on the WebDriver protocol and say, well, that's for web automation, let's go make new protocols for all these other new things, we should instead learn from all of the years of effort and experience that has gone into creating the WebDriver protocol and see how we could maybe tweak it. And who knows, maybe one day those tweaks could become an official part of the protocol. That's the dream anyway. And right now, Appium does extend the protocol, but of course you're not going to go to the W3C and find our extensions because they're not official. So that's the first thing. The second thing that Appium will be, and in fact is today, is a set of code libraries that you can use to write new drivers to plug them in to Appium. So we're going to look in a minute at how many drivers there currently are for Appium. And rather than each of those driver implementations having to solve all the same common problems in order to make them work together with Appium, we've created a set of code libraries that each of them could use to make all that they have to write is the thing which is unique for that driver, the particular way that driver has to translate the protocol into Espresso or XUI test or whatever it is. So Appium will be this kind of loose federation of drivers, which each driver will itself be a WebDriver interface. So Appium becomes kind of like this proxy server rather than anything which has intelligence in it itself. And the drivers are the things which are intelligent. And they're built on top of whatever automation technology is good that's out there. So Google comes out with its new thing, and Appium, somebody in the Appium community decides, okay, it's time to integrate this into Appium. Let's write a driver for it. There's not a competition between Appium and Espresso or Earl Grey or all these other tools that people are constantly thinking about. Which should I use? Which should I use? We want Appium to be kind of an abstraction layer on top of all those technologies, so that what you get is the benefit of those technologies along with the WebDriver protocol. So in a sense, it's sort of, if you think of it in terms of a shim, like we have JavaScript shims for all of these new HTML web technologies that come out. Appium is like the WebDriver shim for every other kind of automation that hopefully someday the vendors themselves would produce a WebDriver implementation so that we don't have to have a shim anymore. But for now, Appium is that shim. It's the stable API on top of a changing set of technologies, which get deprecated and new ones come on stage and all that. And finally, getting all the people who do automation in the same community talking about the problems they experience, either with specific underlying technologies or more generally with how you should automate mobile apps or how you should automate IoT apps. This is actually an overlooked benefit of just getting all these people in the same place, talking, sharing solutions, sharing ideas. A lot of what has made Appium successful is not its stellar technology. It has lots of problems and has always had lots of problems. But there have always been a lot of people out there who've been willing to share how they've overcome those problems, either with Appium itself or with the things that are underneath Appium, or just good ideas about, well, how do you test incoming text messages or things like that. There are ways to do all these things, but they're not obvious. And so people sharing how they've solved these problems has been a really big part of what's made Appium successful, and that's going to be a big part of what we want to continue to rely on. So going back a step, talking about the different kind of driver rainbow of Appium, let's take a look. If we remember the schematic of the iOS and Android platform support from 4 or 5 years ago, what it looks like today is quite a bit more complicated. So we actually still have those original platforms of iOS and Android and instruments and UI Automator, but they have been factored out into their own drivers, and in fact are now deprecated because they're so old, but they're still around. And we've continued to add different drivers to the family. And we rewrote Appium from scratch a couple years ago, really to enable this kind of thing to happen, because we saw that continuing to add platform support to Appium needed to be done in a much more modular fashion than we had been doing it. And so we decided to create a new architecture to enable anyone to kind of write these different drivers that could then just be plugged into Appium in a very clean way. So today we have our kind of flagship iOS support is ultimately relying on XCUI test, Apple's newer automation technology. So there's a driver for that built on top of WebDriver agent, which was pioneered by Facebook and which we've put a lot of our own changes into as well. Google's released UI Automator 2 some time ago, so that's kind of the current Android driver we recommend for people to use. We actually have an Espresso driver that's in beta, so if you've heard about Espresso, it's this even newer automation technology from Google, which enables kind of more stable testing of Android apps because it's focused on making sure that nothing is happening in your application when you're trying to interrogate it for testing purposes, which, as you know from writing Selenium or Appium code, is a big source of bugs. So we're in the process of seeing if this can be a valuable addition to the Appium family. There's a little wrinkle here too, where Appium, unlike some other mobile testing frameworks, also enables WebView and web application testing. And so on Android, we do that through Chrome driver because the good people at Google have actually made a WebDriver implementation for not just Chrome on desktop, but for Chrome browser and Chrome-backed web views on Android. So we call out to Chrome driver from all of the Android drivers if you're doing WebView automation. There's actually a driver put out by Microsoft called WinAppDriver, which is an Appium JSON wire protocol compatible automation server, which is plugged into Appium through our Windows driver. That's built and maintained by Microsoft. So this is kind of the first kind of hopeful signal from a vendor that they're interested in doing something not related to web, but using the WebDriver protocol. And Microsoft is, a company that people have heard of. So I think that that's a really good sign. There are abilities also to automate Mac applications, like Mac desktop applications. Not a lot of people need to do this, so at this point it's kind of a toy, but the technology works. It's actually really fast and interesting, but it's anyone's guess as to whether native Mac desktop applications are going to become a big enough part of the industry to warrant really continuing to support this or not. And then there's kind of this one company that has made their own driver for their own technology to offer their developers as a way for their developers to test their own. It's a TV app kind of technology called UI.tv, but they got on board with Appium. And so that's kind of interesting in that it shows how even organizations with very specific niche needs could create an Appium driver to offer to their community of developers for them to have an easier time testing for their framework. I mean, it's still running on maybe iOS or Android or whatever, but they have a layer of abstraction on top of that that makes it easy for their developers to test using one code base. So that's the drivers of today. And let's go back another step and kind of examine this thing about Appium being a set of code that you can use to easily write drivers. Let's think a minute about, from a technical code perspective, what would writing a driver entail? What does a driver even do? Well, a driver is responsible for setting up your system so that it can run a particular underlying technology. So if there are binaries that needed to be downloaded, like this is what we do with Chrome driver, for example, on Android. When you install Appium, you don't realize it, but Appium is actually downloading Chrome driver onto your system, whether or not you have it. So that when we go to automate a web view, we just call out to this Chrome driver that we've downloaded at a specific version, and you can modify that version and all of that. So you don't have to have Chrome driver somewhere on your system, and this is something that the driver is responsible for, just to make it easy. You know, I know that when I've tried to use Selenium in recent years, sometimes it's like, okay, well this will work, but first you have to go find this other thing and download it, and that's not a big hassle. It's not really a criticism, but it's nice to just have everything already downloaded and configured for you. Then the driver has to actually manage this underlying automation technology as a subprocess. It has to launch it as a system process, and it has to maybe watch it in case that process decides to crash, and then give the appropriate sorts of feedback to the client in that situation. It's also responsible for doing the WebDriver protocol translation. So if the Appium driver is speaking to something which already speaks the WebDriver protocol, then that could be as easy as just simply proxying the command straight through without any additional logic. Or if it's talking to something that doesn't speak WebDriver, like if it's talking to UI Automator 2 or XUI test, then it needs to actually figure out how to translate the WebDriver commands, like a click or a find element, into something that the underlying technology understands. So that's its responsibility. And then if there are bugs in the underlying technology, or if there are omissions in the underlying technology, features that should be there but aren't, and it's possible to implement, then the driver could kind of go above and beyond and implement some of these things. So a lot of our more popular drivers do a ton of this. They notice that, oh, well, on this version of iOS, if you run this command in XUI test, it is broken. But there's a workaround. So we put the workaround into the driver so that users of Appium don't have to know that there's a workaround. It just works. And we can't always do that. We can't always make a perfect experience, but it's at least a place. This is where in the Appium stack we try and cover over some of those flaws. And so try not to add too many of our own flaws. Okay, so this is the intro. I want to try and illustrate how we would actually go about doing some of this stuff by building a driver. So what we're going to do today is we are going to build a Safari driver for Appium. And I picked Safari driver because I think it's just about the easiest thing I could think of to do, and in the 10, 15 minutes I have remaining, we need to move really fast to do this. So we need to set up the system binaries and state for the underlying automation technology, in this case Safari driver. We don't have to do that because Safari driver is already on your Mac if you have a recent version of Safari. So great, easy. We need to manage it as a subprocess, which is what we'll do with our code. We need to translate the WebDriver protocol to the thing that Safari driver speaks, which is still the WebDriver protocol. So we have to do a little bit to make this work, but all we essentially are going to be doing is proxying. And we're going to assume that Safari driver has no problems, and we're not going to try and fix anything else in it. Okay, so let's try some live coding here. And let's switch to my computer, which went to sleep. Great, okay. I've made a little directory here. Open up Vim and check out what it looks like. There's a lot of stuff I'm not going to go into. I'll show you basically the file structure. We have a library directory here where we've got the files we're going to be working with. But of course, we want to start with some tests, right? So I've gone ahead and written our test. Basically, I'm using JavaScript, so I'm sorry if this is something that you find disgusting. But this test basically imports our Appium Safari driver, starts it listening on a host and port. Of course, it cleans it up afterwards. And then we just use a WebDriver client using WD here. We initialize it with the browser name capability. And we're going to my Appium newsletter website, filling in a form, and asserting that there's a particular string in the error response because unfortunately we are a robot, so we're not going to break Google's CAPTCHA thing. And then we quit the driver. So that's the test that we're going to run to make sure that this all works when we're done. There's a server file which basically just exposes this Appium driver code as an actual web server that we can call rather than having to import it in memory. There's a little logger that we're going to use so we can write things to the console in a pretty fashion. And let's first try and do the subprocess management bit. So before we can proxy anything to Safari driver, we have to have a running instance of Safari driver on our system. So we'll call this, we'll have a class, we'll call it Safari driver proc for process, and of course we're going to want to export this. In this class, we're going to want to keep track of a few things, like we might want to run Safari driver on listening on different ports. So we'll take a port option, and we might want to tell somebody who's calling this code if Safari driver process dies unexpectedly, so we can pass in a handler for that. We're going to keep track of our actual subprocess object locally in this.proc, and unexpected handler. Okay, so now what are we gonna actually need to do? First of all, we're going to need to start the subprocess. So we'll make a start method. We're going to need to stop it. And we'll also create some kind of local handler methods for, if the process stops, we want to log a little message. So this is something that we're going to call. To log things, we'll need a logger. We'll create a new logger called Safari driver proc. But to use the logger class, to use the logger method, we need to import it from Appium support. And Appium support is one of these collections of utilities that are useful for writing drivers, like I was talking about. Okay, so when the process stops, if we've told it to stop, that's good. It stopped. We told it to stop. And we can just say Safari driver proc stopped OK, or whatever. But now it might also stop in a way that we didn't want it to. It might die when we didn't tell it to stop. So we need a little handler for what to do in that case. And basically, we get a code and signal that we can use, so we can make a little error message saying, died with code and signal, right? And then we want to, first of all, just log that out because that's bad. We want people to know what happened. And if we have our handler connected, like the person that's calling this Safari driver proc code, we want to let it know that something bad happened. So we'll just go ahead and call it, and we'll pass in the error. So if it needs to do anything with that particular error, it can. Great. Okay. So let's actually handle our. Let's actually start our process when we call start. First of all, we probably want to kill any existing instances before we start new ones, because that could complicate things. So we will go ahead and import a couple other modules here from Appium support that would be useful. So let's call kill process on anything that looks like it might be Safari driver. We might not want to write this actual code, but we're going to do it for the sake of demo. And then we need to know where our Safari driver is on the system. So we'll use a handy which method. So this will either throw if it can't find Safari driver, or it will give us the the absolute location. So now we can actually start our subprocess. We'll take advantage of a handy subprocess class, which does this very nicely. And we'll start Safari with the arguments -p, Safari driver with the argument -p port, because that's how it's set up. And of course, before we use subprocess class, we need to import it from the teen process package. And then we listen to a couple things. We can listen to the stop event on the process if it ever stops. And then if that happens, we just call our own onProc stop method, which we just made. If it dies, meaning it stops without us having told it to stop, then we call our onProc die method. And then we also want to give the user feedback if something comes out of standard error, standard out. So there's also a streamline event we can listen to. And for that, we just want to log to the debug method of our logger, which we've created. So these are just things that we want to kind of bind on the subprocess before we actually kick it off. Now we're going to kick it off. So we'll say starting subproc or whatever we want to say. And we will await the start of our actual subprocess. And I'll just give it an argument of a numeral 0, which basically means just wait for 0 milliseconds and then assume that it started. And this is because Safari driver doesn't log anything out when it starts, so we can't wait for standard out to tell that it started. But that's okay. We'll assume that it starts, and then we'll make sure that it started actually by just sending it new session commands until it works later on. So then to stop the subprocess, basically we just first want to make sure that we actually have a subprocess running. So if not, we can just return silently. Maybe we could log a message if we wanted. Now we'll say stopping Safari driver proc. And we'll just put this in a try catch block because we don't really care if it succeeds. And we will call stop on the subprocess itself and be very nice and send it sig term. And we'll wait 20 seconds for it to maybe work or not. And then finally, we'll clean up our process, subprocess object so we don't think we're running any subprocesses anymore. So this is a nice little class. I should be writing a little more clean here. So we've got our Safari driver class. We made a start method, a stop method, and some event handlers. That's basically all there is to it. This is what it takes to launch Safari driver. So let's make now our driver class, the one that actually interprets WebDriver requests and ferries them on to Safari driver, which is now going to be launched by us instead of someone having to do it on the command line. So let's create a little class for this, Safari driver. And I mentioned before that Appium involves a set of base classes that are useful for writing drivers. So this is where we're going to see that in action. So we will extend Appium's base driver class. So of course we have to import base driver from Appium base driver module. We need a constructor. You can pass in some options. We're just going to pass them right onto the parent and not really do anything with it at the moment. Let's think about what other methods we might need in a driver like this. I'm going to cheat because I know the end of the story. I know what kinds of things we can subclass from, or we can override from the base driver class that are going to be relevant for us. So we're going to have a method which returns whether there's a proxy active. In other words, are we currently proxying to Safari driver? A method which tells us which WebDriver commands we shouldn't proxy, if there are any. And a method which says whether this driver is the kind of thing which in general can proxy. And of course, that's going to be true because we're doing all of our commands as just proxying them onto Safari driver. We're not doing anything special with them ourselves. And likewise, we're not going to avoid proxying any kinds of WebDriver commands. We're not going to trap the click command and do something special. We're just going to pass it right through to Safari driver. And proxy active is going to return true if a proxy is active. So let's actually create some state in our model here so that we can track that. So I'll make a little method called NetState because we're going to call it a few times. So I'll call this .safari referring to Safari driver itself. Proxy is going to be our proxy handler. There's something else. This is a magic name called proxy rec res, which proxies entire Node.js responses and requests. And of course, our is proxy active, which is going to start out as false. So proxy active here just returns if the proxy is active. Great. So then the other two things that we're going to need are handling of the create session and the delete session, because those are the things that this driver is going to be responsible for. Everything else, we're just proxying straight through. But this has to handle create session because it has to start up Safari driver as a subprocess, and it has to handle delete session so that it can clean up what it did. So these are async methods. So delete session here. So let's look at create session first. So of course we want to call the base driver implementation first. That gets us out a nice session ID and a nice revision of our capabilities that were passed in. So once we've got those, we can start Safari driver as a subprocess and create a new session using the capabilities that we just extracted. And we want to do all of that inside some error handling because if anything blows up, what we then want to do is stop Safari as a subprocess so that it's not hanging around in case anything went wrong. So we'll just go ahead and write that code right now. If something goes wrong, stop Safari driver subprocess, and then continue on throwing the error so that the user gets the feedback that the session was not created successfully. Okay, so what are we going to do to create the session? Well, we make use of our Safari driver proc class, which of course we now need to import. Driver proc from, this is just a local file here. Right. And then we pass it the port that we want. I'll just hard code it here to something like, I don't know, 4912 or whatever, which should be either an option to the server or a constant or something else, but we'll just hard code it. And then we have our unexpected exit handler, which is called whenever Safari driver might die on its own. Of course, in this demo, hopefully it won't do that, but just to show you how that would get passed up the chain and eventually return to the client, we make use of a method that we have on base driver called start unexpected shutdown. So that basically will go back to the base driver code. If there's a command in flight, it will respond to it with an error. It'll kill the session. It'll make sure that everything is clean. So if the client keeps sending requests for the session, returns a 404, blah, blah, blah. Now we can go ahead and start our Safari driver subprocess using, using the start method that we implemented. And then let's hook up the WebDriver requests to Safari driver with a proxy. So we'll make a new proxy, and we'll use a JSON wire proxy class here that we, of course, need to import. Oops. And we'll pass it some options. Safari driver only runs on localhost, so we can just hard code that. We'll again hard code our port that we're proxying to. There's no URL base like wd/hub or whatever, and we'll say that commands need to happen within 5 minutes or they're considered dead. And now what we're going to do is just send new session requests to Safari driver until it responds to them, and that's how we'll know that Safari driver is online. So to do that, I'm going to use a handy method called Retry Interval. And we're going to try up to 5 times once a second. And what we're going to do every time we try is proxy a command, the post/session command, with a payload that looks exactly like it's supposed to. In this case, desired capabilities. We pass on the capabilities. Boom. So once we've got here, we know that we have a new session already set in Safari Driver, and the Safari window should be open. And we're going to just, at this point, turn on proxying entire Node.js requests and response objects so that subsequent requests from the client just go straight to Safari Driver, and we don't have to do anything. And we turn on our proxy, and now we finally go back and return the session ID and capabilities that we got from base driver. Okay, we're almost there. So let's just say, like, we're deleting the session. When we're deleting the session, we're now implementing the delete session method. We want to make sure we call any kind of cleanup that happens on the base class. And we'll do the actual delete session on our running instance of Safari Driver. So we need our session ID here to do that. And it is, of course, the delete HTTP method. And once we've deleted the session, now we want to go ahead and kill Safari Driver. We could leave it open if we wanted to manage it that way, but I prefer to just start and stop it every time we have a session. And then we'll go ahead and clear out our state using our NetState function. So this is it. So let's see if it worked. First of all, I have a syntax error, so that's not good. Thank you, linting. I need another dot here. Should always use a linter, especially when you live code. Log is not defined. That's because we haven't ever defined a logger. So let's just import our happy little logger there with some happy little code and Bob Ross joke. Okay, let's go over here and see if we can run it. So because Appium is using really new JavaScript, we're using JavaScript that's so new that Node can't necessarily run it directly. We have to transpile our code. And then let's try running the test that I showed you earlier, which just, again, loads up my website and all of that. And we should see all the logging that we wrote. And, oh, right, yeah, so the desired capabilities object wasn't valid because Appium expects a device name and stuff like that. So let's just tell base driver, don't actually validate desired capabilities, things like that. Device name, did I? Super ops false. Oh, I guess, of course, I didn't transpile. In case I have to do any more fixing, we'll just put that at the front of the command here. Command must be a string. Dun, 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 dun. That's not good. Desired capabilities, escapes, proxy command. Okay, well, we're running out of time, so instead of trying to fix this, I'm going to check out a version that I'm pretty sure might have worked at one point. Yep, okay, so the code should mostly be the same as what I tried to do anyway. So here we have Safari Driver launching up, finding the error and working. And if we can go back to the slides, I'll just wrap up real quick. So unfortunately, the live coding exercise was not totally successful, but I tried really hard for you guys. We'll pretend that it worked because that's what I put in the slides happened. So that's what posterity will remember. So that's basically it. Thanks for your attention. Hopefully what I've shown you is that apart from live coding problems, you can write an Appium driver in like 100 and 120 lines of code as long as you're doing something simple like proxying to Safari Driver. Of course, there's no reason to do this really because Safari Driver you could just launch on your own rather than launching through Appium. But if you had something else, this is how easy it is basically to to leverage the code libraries that Appium provides to make totally new automation libraries that plug right into Appium. So make sure you come to Appium conference in just about a month. And I don't have time for questions, unfortunately. So come talk to me afterwards. Thank you.